This is homework set 31 on variation, questions 7 through 10. Question 7. We are told that the length a spring stretches is directly proportional to the force applied. All right, so here's what's going on. Suppose we have, all right, here's like a ceiling or a roof or something, and you hang a spring down here. All right, and then what you're going to do is you're going to stretch it. Okay, so you're going to stretch the spring. So that's the spring at normal length. Then you put a weight on it here, some kind of force, and that will, force this thing to get longer. So we're told that the length the spring stretches is directly proportional to the force applied. All right, so the bigger the force, right, the bigger the weight down here, the more the spring is going to stretch. So now let's write our general variation equation. We are told that the length it stretches, so the length it stretches is directly proportional. I don't see the word inverse, so no fractions. Proportional means variation. Directly proportional to the force. Right, there's the force. So that is our general variation equation. Now, what do we know? We know if the force is 3 pounds, so if F is 3, the spring will stretch 10 inches. So we know this. 10 is equal to K times, what did we stretch it? 3 pounds. So K is equal to 10/3. All right? So put that back up into our general equation. L is equal to 10/3 F. There's our particular variation equation. Now, what do we want to know? How much force is necessary to stretch the same spring 8 inches? All right, so I want to find F. How much force is necessary to get this spring to go 8 inches? All right, so how about 8 is equal to 10/3 F multiplied by 3? I'll get 24 is equal to 10F divided by 10. 24 divided by 10 is F. Now, this is equal to 2.4, and this is all in pounds. Or if you just want to leave it as a fraction, you could leave it as 12/5 pounds. Okay, either one will do. Question 8. The capacity of a cylinder, that means how much the cylinder will hold. The capacity of a cylinder varies jointly, multiplication coming up, with its height and the square of the radius. Okay, let's write that. Actually, here's what we have. Here's a cylinder, like a can. Okay, and here is the radius, and here is the height. All right, now, does it seem reasonable that if you make the radius bigger and the height bigger, we'll get a bigger capacity here? Sure. So here's what we have. The capacity of a cylinder, now that's volume. That's the capacity, it's a volume. Write C if you want. This varies jointly. Now, I don't see the word inverse anywhere, so no fractions. Jointly, so that's a multiplication with the height and the square of the radius. Except I forgot the K. All right, let me do that one again. So it varies jointly. All right, varies. As soon as I see varies, all right, with the height and the square of the radius. All right, there's our general variation equation. This is true for any can. But now, for this particular can, here's what we know. If a cylinder with a radius of 3, all right, so this is going to be a 3, and a height of 6, has a capacity of, okay, let's just do this, 169.56, that's equal to K times H. What was the height? It was 6, and the radius was 3, so 3 squared. This will give us 169.56 is equal to, now, 3 squared is 9, 9 times 6 is 54, so I'll get 54K. Now, so K is equal to 169.56 divided by 54. K equals, what do you know? Recognize that? 3.14. All right, so here's our particular equation. V is equal to 3.14 HR squared. And now what we want to do is this. What will be the capacity of a cylinder with radius 3 and height of 4? All right, so what is the capacity? What's the volume? 3.14. when the height is 4 and the radius is 3. Okay, so I just put those numbers in here. Straight computation. And when I did that, I got that volume is 113.04. So the capacity is going to be 113.04 cubic centimeters. Okay, how about 113.04 centimeters cubed? Okay, there we go. Question 9 tells us that the resistance of a wire varies directly with its length and inversely, there's inverse, fraction bar K on top, with the square of its diameter. So let's get that. How about R for resistance? So the resistance equals, fraction bar K on top. Now what else goes on top? Varies directly, that's on top, so with its length. So the length goes on top, and then whatever follows the word inverse goes on the bottom. So inversely with the square of the diameter. So how about diameter squared? Okay, there is the general variation equation. Now, we're given some numbers. If 100 feet of wire, so the length is going to be 100, with a diameter of 0.01, has this resistance. Okay, so the resistance is going to be 10 ohms. That's equal to K times 100, that's the length, over I better do it this way, 0.01 squared. We can get K. This will give us 10 is equal to 100 K over 0.0001. Right, go ahead and square this. Now, I'm going to do this division. 100 divided by 0.0001. Turns out that that is a million. So 10 is equal to 1 million K. And I can get K if I just divide that. So K is going to be 10 divided by a million. So K is equal to 0.0000, and I think we're going to get a 1 here. All right, so I'm going to take that value of K and I'm going to put it right back up into this original. And that'll give me that R is equal to 0.4 zeros and a 1 L over D squared. All right, there is a particular variation equation. And now here's what we're asked to do. Got all that. What is the resistance of 110 feet? Okay, so now I'm going to put 110 here if the diameter is 0.02. All right, so here's what I want. The resistance is going to be 0.1234 and a 1 times, we got 100 feet of wire all over the diameter, which is 0.02 squared. So this part right here, I know if I multiply by 100, I just move the decimal points over 2 places. So this is going to be that R is equal to 0.001, I'll put a leading 0 out there, over 0.0004. Let's make that division. Right now, I got R to be 2.5, but I just saw something here. You see what I did here? I put 100. What should it be? It should be 110. Right now, if you put 110 in here, what you're going to get is R is equal to 0.1234 and a 1 times 110 over 0.02 squared. And that comes out to give you R equals 2.75. So it's going to be 2.75 ohms. Now here in question 10, we're told that the volume of a gas varies directly with its temperature and inversely, fraction bar K on top with the pressure. All right, so here's what we know. The volume, now, I saw the word inverse, so fraction bar K on top. Now, what goes on the top? Anything before the word inverse. So what is that? that's temperature. So the temperature, so I'll get K, T, and then inversely with the pressure. Okay, so inversely, so P. There is the general variation equation. Now, what do we know? We know that the volume is 20. All right, so the volume is 20. That's equal to K times, now what are we getting for that temperature? The volume of gas is 20. When the temperature is 300, right, so 300 Kelvin. Okay, 300 Kelvin over, now what's the pressure? When the pressure is 30 pounds. Okay, pressure is 30 pounds. All right, so first of all, that zero will go with that zero, and then I get 20 is equal to, now 330 will go 10, 10K, K is equal to 2. So put that 2 back up here into the general variation equation, and here's our particular equation. V is equal to 2T over P. And now what we want to do is this. What is the volume? So find V when of the same gas when the temperature is 320. All right, so V is equal to this fraction, 2 times 320, and the pressure is 40. Okay, so the volume is, this is actually going to be what? 640 over 40. Those go. So the volume is 64 over 4. So the volume is, that's a 16. So I'm going to say 16 cubic feet. And that brings to an end homework set 31.